Good morning, children. In today's class, we are going to learn about conic sections. What are these sections actually? If you have a cone and if I slide it using a plane, intersecting a cone with a plane, it may cut this part alone, or it may cut like this, or it may cut horizontally, or it may cut little inclined. So I get various shapes, and suppose it is a double cone, and when I slide it with a slanting plane, a part will be on top and down. So such parts we call conic because they are derived from a cone. Part of a cone when I intersect with a plane, either horizontal plane or an inclined plane, we get the various shapes, and that's the name conic. We have three different types. The very first one, earlier we learned the circles. When I cut the plane horizontally, remember when you eat cone ice cream, the heat part is gone. You have the flat surface which is like a circle. But if you keep on eating in the side, you may have a little curves like this way. C shape, I will say. Opening right or left or up or down, I call them as parabola. And if it is like an elongated circle, we call it as an ellipse. And if it is an open parabola, up and down or right and left together like this way or like this way, I call them as hyperbola. So this section, we are going to learn the three different shapes. A parabola may be like this or like this or like this and like this. An ellipse may be like this way, flattened like this, or it may be like this also. So there are four types of parabola, two types of ellipse, and two types of hyperbola, which will be dealt in detail in this section. How to frame the equation of a conic. To derive the equation of a conic, we need a fixed point and we need a fixed line. So I am writing two things. We need a fixed point and we need a fixed line. A point is moving like this. How does it move? A point is moving. Say it is P. As it keeps on moving, the distance from the fixed line and the distance from the fixed point bears a constant ratio. Call the fixed point as focus. Call the fixed line, say it is L, which I can call as directrix because it directs the curve. It directs the point. So it is called directrix. The fixed point I call focus, and this distance let me call M. And now I will say SP by PM is a constant ratio, and that constant we call E, and E is called eccentricity. The letter E in this chapter we denote for eccentricity. This E can be equal to 1 or below 1 or above 1, being a ratio. If SP and PM are equal, in that case E is 1, I get a parabola. So whenever E is equal to 1, I get a parabola. And E is less than 1, I get an ellipse. And E is greater than 1, I get a hyperbola. So the three different shapes we decide using the value of E. E is below 1, it is ellipse. Above 1, it is hyperbola. And equal to 1, it is a parabola. How to draw a parabola? If you are given a fixed point and a fixed line, keep the points in such a way that distance from S and distance from the fixed line are equal. So that we called as parabola. We have kept x-axis, y-axis. The fixed point we call as focus and the fixed line we call as directrix. How to draw the parabola? The distance from the directrix and the distance from the focus must be equal. See, this stick and this stick same size we have taken and they join here. So that is a point. We have taken another two equal sticks and one at the focus, one from the directrix. This distance and this distance are equal. Mark a point here. We have taken it another two equal size sticks and from here the perpendicular distance from the fixed point, the distance, both must be equal. They meet here. So join all these points to get the parabola. Just joining all the points. One point here. So the curve we have traced is a parabola. This distance and this distance are equal. Distance from a fixed point and the fixed line. Distance from a fixed point and the fixed line. The same idea here, and these points as I join, I get a parabola. What all we must know in a parabola? This point where the curve and the line of symmetry. See, this I call line of symmetry because the above and below are looking the same. The curve that is above this line and below the line are same. Something that I can divide into two parts is called symmetry. So this x-axis I call axis of symmetry. The fixed point we denote as S, which is called the focus with the coordinates a, 0. This distance and this distance must be equal. So we analyze an important condition from the vertex to the focus. This point we call vertex, where the axis and the curve are cutting. We call it as vertex. Vertex to focus we call the distance to be a. Vertex to directrix also the same distance. That is the equation of a parabola. Now we know what is a vertex 0, 0, what is a focus a, 0, and what is the axis x-axis. I say y equal to 0 is the equation. And what is the directrix? This is 0, 0. This is to the left of it. I will say x is equal to minus a. If focus is plus a, directrix will be minus a. Focus is to the right and directrix is to the left, parallel to this axis, y-axis. So this is how we draw a parabola. Remember, we say this is opening right. We have the four types of parabola. The curve opening right, the curve opening left, the curve is opening up, and the curve opens down. So right, left, up and down, there are four types of parabola. X-axis, y-axis can be anywhere. We mark the vertex to be h, k. Because every time 0, 0 cannot be the vertex. So it is good to learn the equations of parabola with h, k, any arbitrary point, that as a vertex. So we have taken A, the vertex, as h, k for all the four types. How to write the equation? For this curve opens right, we have y minus k the whole square equals 4a into x minus h. The same is here but negative symbol. The same is here but x and y are interchanged. X minus h goes to the left, y minus k comes to the right. So we have the third equation, and the fourth is same but negative symbol. So here only the symbol changes. Here x and y are interchanged. This x minus h goes to the left and y minus k comes to the right. Remember, all these four formula you must be thorough with. Now the idea is focus. Focus. What did we learn in the standard type? We learned the focus to be a, 0. Now the vertex is h, k. So what should I do? H, k, add with that. So what is the focus now? H plus a, k plus 0. The same idea when I come here. It is this side. So it is minus a, 0. See, focus is to the right. It is a, 0. Add with h, k. When it is to the left, it is minus a, 0. Add with h, k because h, k is the vertex. And when it is opening up, now the focus is here. It will be here a, 0, here the standard model a, 0, it will be reversed. So 0, a, add with h, k. And when it is opening down, it is 0, minus a and add with h, k. So these are the ideas in all the focus or vertex or wherever we write, add hk. Remember, for x you add h, for y you add k. Remember that. Here a0 we add, here minus a0, here 0 a and here 0, minus a. How to write the directrix? What is the directrix? The fixed line. The curve goes right, directrix is left. Curve goes left, directrix is right. Curve goes up, directrix is down. Directrix will not intersect the curve, remember. Curve comes down, directrix is up. Now how to write the equation of the directrix? You have to remember these equations from which we will write the directrix. To remember, x minus h, here plus symbol means plus a equal to 0. X minus h plus a equal to 0. How to write here? The directrix is x minus h minus a equal to 0 because minus sign is there. Remember in that way. X minus h minus a equals to 0. And when you come here, y minus k only is here. So y minus k plus a equals to 0. And this part y minus k minus a equal to 0. So when you are learning, compare all the four types and learn together. Tabulate like this so that it will be easy for you to remember. Now lattice rectum. Lattice rectum is a card passing through the focus. So this only we call lattice rectum. Lattice rectum is perpendicular to the axis and it is a card passing through the focus. So two ideas for lattice rectum. It is perpendicular to the axis. I cannot be drawing like this and all. Inclined I mustn't draw. A vertical line. Vertical line, or I will say it is perpendicular to the axis and passing through the focus. So here I can draw like this, here I can draw like this, and here. Now we ought to know what is the length of the lattice rectum. In this equation, or in y square equal to 4ax, the standard form, let us substitute. This is passing through the focus, means that focus coordinates you substitute and you get the length as 4a. So we get for all the four patterns, 4a is the length of the lattice rectum, that which comes here in the equation. So this 4a only we remember here as the length of lattice rectum. Now the next is axis of symmetry. How to write the axis of symmetry? This line we call axis of symmetry. From the equation, put the LHS equal to 0. Y minus k whole square, no need, only this bracket. So axis when I want, it is y minus k 0, it is y minus k 0, it is x minus h 0 and it is x minus h 0. So remember the technique of remembering the formula. Focus will be, in all the cases, put h comma k. Here add a0. Look at this. This is a with x. So with x you add a, the other one is 0. Here also x only is coming but minus a. So with x you put minus a. Here y is coming, so with y value you have to put plus a and with y value you have to put minus a. For directrix, x minus h plus a equals to 0, x minus h minus a equals to 0, y minus k plus a is 0 and y minus k minus a is 0. For all the four cases, certain things are same. The vertex and the length of lattice rectum. Now, the axis of symmetry will be the LHS bracket. Put that as 0. So, these are techniques to remember and attempt your objective type or even 5-mark questions. Now, we have to remember certain things for applying in the problems. Vertex to focus. We can see from our original diagram. Vertex to focus. What is the distance we have taken? A. Vertex to directrix. What is the distance? That is also A. So focus to directrix, the distance is A plus A, that is 2A. So we have written all this as a formula. A to S, that is vertex to focus, A. Vertex to directrix also A. Focus to directrix, it will be 2A. Remember all this while doing exercise and example problems. The second concept, ellipse. How to draw an ellipse? See, we all know how to draw a circle. We mark the center, we take a radius, we turn around to get the circle. For an ellipse, fix 2 points, the focus, because in parabola type we had only one focus. But ellipse is a closed elongated circle, we say, in which there are 2 curves. So there will be 2 focus. How to draw it? In the 2 focus, the 2 fixed points, you fix some length, constant length. Okay, mustn't change it. This is a constant length. Now, this I mark as a point. See, we can mark it as a point. This is a moving point. My sketch pen, the end of the sketch pen is the moving point. It is here. I can keep on moving. See, stretching out from the 2 points. I keep on moving and I get, see the pattern as I draw. So we get a ellipse. So fix this distance as 2a. What is this distance I have taken? S to S dash. In between I take this P. So SP plus S dash P is the length of this thread. SP plus S dash P. This length together, that is adding, I fix it as 2a. As I fix it as 2a, I draw the ellipse. So this is the basic idea of ellipse which we will use in the problems. Can you remember any shapes of ellipse like this? Remember, the Coco players will be sitting along a line. The person who is running about, will form an ellipse. These problems, we use this idea. SP plus S dash P equals to 2A. Now what is the equation of an ellipse? I must know the two distances from C to the which I have drawn this distance, and if I have the vertical line like this way, which I call y-axis, this is y-axis and this I call x-axis. Call this distance as B. Notice x-axis is bigger, the length, and y-axis is little smaller, call it as B. So in ellipse, the major idea to remember is A greater than B. So this is first type of ellipse where under x we have bigger number, under y we have smaller number. When you have A and B, what is the relation connecting A, B and E is very important. Remember, B square equals A square into 1 minus E square. We will apply this in the problems. You can rearrange this equation and write what is E. E is equal to 1 minus B square by A square. From 1, I subtract some fraction. That tells me E is below 1. From 1, I subtract some positive quantity. B square by A square. A is bigger. So this will be like 1 by 2, some decimal, 0.1, 0.2, something like that. So when I subtract from 1, E value becomes less than 1. Remember the idea. These 2 points I call vertices. And vertices, the distance is A. So this is A comma 0 and this is minus A comma 0. Focus. These two fixed points I call as focus or foci in plural. For foci, we give the formula plus or minus C comma 0. What is this C? Calculate C as AE in one way. If you know A and E, C is equal to AE. Or else, assuming in this formula, I arrive C is equal to root of A square minus B square. So focus formula plus or minus C comma 0, where C is equal to root of A square minus B square, or I can say C is equal to A into E. Now there are two focus. So I can draw the lattice rectum in two ways. Here one lattice rectum and here. What is the formula for lattice rectum? It is passing through the focus. Focus is plus or minus C. So lattice rectum equation will be x is equal to plus or minus C. What is the C actually? It is A into E. Then we need to know what are the two directrices. So here I have a directrix and here I have a directrix, because there are two curves. This is one directrix and this is another directrix. For this directrix it is A by E, and for this directrix it is A by E but negative symbol. X is equal to minus A by E and x is equal to plus A by E. So as I say directrices, the plural form, we have x is equal to plus or minus A by E. This we call standard form of an ellipse. The first type where A is greater than B and bigger number is coming under x square. Now as I know how to draw this ellipse, I must know the second pattern of the ellipse also, as well as the center changed to H comma K. So in practical life problems, we cannot always expect center to be 0 comma 0. So we must know any formula with H comma K as center. And remember, it is not difficult. From the standard pattern, wherever this x and y coordinates we write, add H here, add K here, everywhere. Wherever I write coordinates, add H, add K, and that is the answer. So we have vertices plus or minus a comma 0, focus plus or minus c comma 0, where c is equal to root of a square minus b square, and directrices x is equal to plus or minus a by e, and lattice rectum x is equal to plus or minus c, because lattice rectum passes through the two focus. We see the two types of ellipse. First type, second type. In both the cases, h comma k is the center. So how to write it? Using our standard pattern. So the first case, we said vertices plus or minus a comma 0. How will I write here? Add h, add k. So h plus a, h minus a. The second one is k only. For focus, plus or minus c comma 0. Add h, add k. So h plus c, h minus c here, k only will come. For directrices, we learnt x is equal to plus or minus a by e. We learnt x is equal to plus or minus a by e. So with that add h. X is equal to h plus or minus a by e. Now the very important formula, SP plus S dash P equals to 2A. When I see the diagram, this length we call major axis. We said this is A. So A plus A. The major axis is 2A in length, and the minor axis, the smaller one we call minor, the bigger one we call major. So major axis is of length 2A. Minor axis is of length 2b. Have that in mind for both the types of ellipse. Now, the second type of ellipse is just reverse. Here we say x minus h the whole square by a square plus y minus k the whole square by b square equal to 1. When I come up to the second pattern, a square the bigger number will come under y square, and b square the smaller number will come under x square. And we know c is root of a square minus b square, or c square is a square minus b square. So the same formula only, but here I add with x values. Here I add with y values. Whichever is bigger, you have to change that only. The other one will remain as it is. So learn the formula by heart. Here also we remember a technique of doing the problems. Center to focus. What is the distance? So as I see, center to focus, we call A into E, or I will say that is C. Center to focus, either I call AE or I remember it is C. C is root of a square minus b square. Some exercises we use this idea, whereas in some application problems we use this idea. Once I know A and E, it will be easy for me to get b square, which is a square into 1 minus a square. So remember, center to vertex A. Center to focus we call C, which I can write AE or root of a square minus b square. The next idea, center to directrix. Center to directrix is a by e. Center to this directrix is also a by e. It comes in right plus a by e. It comes in left minus a by e. So what is distance between the two directrices? Here a by e, here a by e, together 2a by e. So all these things we have written as a formula to apply in objective type questions. Length of major axis 2a, length of minor axis 2b, and we have center to focus, the distance is AE, and b square equals a square into 1 minus a square. The same idea of ellipse we shift to hyperbola. The only condition is, Here c square equals a square plus b square. Here anything can be bigger. Then how to identify which is type 1 and type 2? In type 1, we have x minus h the whole square to be positive. In type 2, we have y minus k the whole square to be positive. So this is positive first case, y is negative. Here y minus k the whole square is positive, x minus h the whole square is negative, and this we call type 2. Because we don't say which is bigger, smaller, all that. I cannot give the name major, minor. In ellipse, the bigger one I call major, the smaller one I call minor. But in hyperbola, the line that cuts the curve, this line which cuts the curve, I call transverse. So first type, x is the transverse axis or it is parallel to x-axis. In the second type, whenever it is parallel, this is another axis. So put x dash and y dash. These are not x and y. X and y will be somewhere here. Is the idea clear? So this is x dash and y dash. Because we have taken some other center, do not mark them as x, y. X dash, y dash only everywhere we mark. Well, so here I say major parallel to x-axis first type, major parallel to y-axis second type. Whereas here, transverse parallel to x-axis first type, transverse parallel to y-axis second type. The word transverse means line that is cutting the curve. This is the line that is cutting the curve. Here, this is the line that is cutting the curve. So same formula will repeat in type 1 and type 2. Ellipse and hyperbola almost same. The only condition that differs, in ellipse we say e less than 1. In hyperbola we say e greater than 1. And in ellipse c is equal to root of a square minus b square. Whereas in hyperbola c square is equal to a square plus b square. And the most important idea that we say here, SP plus S dash P is 2A, and in hyperbola SP difference S dash P is equal to 2A. Here major axis length 2A, here transverse axis length 2A. Here minor axis length 2B, here conjugate axis length 2B. So the line that cuts we call transverse and the other line we call conjugate. Length of lattice rectum. It is the same for ellipse and hyperbola and the formula is 2b square by a. In parabola it is 4a. In ellipse and hyperbola the formula is 2b square by a. In ellipse, b square is a square into 1 minus e square, whereas in hyperbola b square is a square into e square minus 1. See, the symbol slightly changes. Here it is below 1, so 1 minus e square. Here it is above 1, so e square minus 1. So these are the ideas that we have to remember for doing the exercise problems.